Hello, everybody. Welcome to one of our Java Poland community events. It's really nice to have everyone here. I think that this is also the last event this year for the whole community. So thanks everyone who's been around for the whole year. Um, this event is talking about Hazelcast, which is related to Kubernetes. Kubernetes is one of our most wanted, required skills for the new Java positions that have been opening. So it's a very interesting topic. It's a very relevant topic for anyone looking for different positions or even to grow into the technology, into the discipline, right? Anyway, I hope you guys enjoy, and we are ready for Nikita. Let me invite Nikita to the stage. So yours, man.
Hello, guys. Yeah, so let me start with a small introduction. My name is Nikita. I am speaking from Warsaw, Poland. I am software engineer, and today I'm going to present you and discuss Hazelcast memory data grid architectural patterns in Kubernetes. I'm going to make some introduction about Hazelcast itself, and then we deep dive into patterns and their implementation. Especially, we will focus on embedded patterns, sidecar, and client server. Here, as you see, reverse proxy and reverse proxy sidecar, they visualized as zombie patterns, and later we'll talk about that and why it's so. Okay, Hazelcast. Let's talk about platform a bit. So platform is way beyond the topic of today's presentation, because platform is distributed real-time data platform. It could stream processor data. But what we're going to focus on is what called here on the image fast data store. It's represented by Hazelcast in-memory data grid. As name implies, Hazelcast memory data grid provides you a variety of data structures, distributed structures, first of all, that you could utilize for your own needs. And here we need to distinguish two sets of these data structures. First one is standard utility collection, like map, set, list, queue, which is familiar to any Java developer. And this data structures works out of the box. So if you spin up a cluster, you could get any of this collection, fill with data, get data from it, and everything is cool and super fast. And concurrency utilities. They may require some preconfiguration, because concurrency utilities require some consistency to work appropriately. Out of the box, they're working, but they're working in so-called unsafe mode. It might be enough for you, but if you really need consistent collections, then some preconfiguration must be done. We go in next to licenses. There are two types: open source and enterprise. I most probably would say that open source license would be more than enough for any use case you could need. But enterprise license, you could consider for buying it only in a few particular cases. One of them is persisting your data structures to local disk. It means if entire cluster goes down, your data will be saved. Open source license does not provide such capabilities. Also, blue-green deployment might be the case to consider it. Wide area network replication and management center. This is UI tool to see what's going on inside your cluster, how data is distributed, see some metrics. But you could use regular metrics from your application and create Grafana dashboard. So I think it could be partially mitigated, lack of such feature. Also, before we go to Kubernetes, we need to understand how the members form the cluster. And this is a paramount thing here, because we need to distribute our data and make synchronization between them. And we have two options. Option number one, this is the default option, DNS lookup. It has some pros and cons. Pros is very easy to configure because it's it works out of the box. You just deploy your application with Hazelcast library, and they will use TNS lookup to find each other. So it's minimal configuration, easy to use, but it has some limitation. Kubernetes API, on other hand, is very flexible. It provides you some level of control over how your traffic goes inside Kubernetes cluster. From cons, from official documentation, they say that it requires setting up role binding, but honestly, it's not a big cons. You just do it once, and most probably will never modify it in the entire life of your project. Okay, let's discuss our application stuff. So here you see very classic situation. We have deployment with two pods. Inside this pod there are container with our application, and we have application service that distribute traffic between two of them. It works fine until we need to do some synchronization. Let's say we wanted to employ distributed cache or distributed log mechanism, or we want to implement our custom rate limiter functionality. In this case, it might be thread as a state of application, and we need to store it somewhere. Together with that, we need to make sure that both pods aware about it. And the way how we could do it is first our pattern embedded. We include Hazelcast as library into our application, provide some configuration, and through this Hazelcast we could share some state, cache, logs, counters, whatever. I'm going to talk a lot about that because I want to jump into the coding part and see how it could be implemented. Before we start implementation, let me do a quick introduction about application itself. Let's see what we have here. We're going to expose two REST operation, get cache value by the key and put cache value by the key. Very straightforward. In original step, we're just using concurrent map. It means this cache per pod. So any other pod in the Kubernetes cluster is not aware about this particular one. It's a standard Spring Boot application. The only customization I made here, I exclude Spring after configuration, because we're going to do this configuration by our own to see what's going on inside. Few Kubernetes scripts, application deployment. Here just regular Docker container that's exposed port 8080. We're going to spin up 3 of the spots, and we have a service that's also exposed port 8080. And we're going to use scaffold to streamline line building and deployment of our application to local Minikube cluster. So I'll execute the command to grab some metrics. As you see, each pod right now with basic setup without Hazelcast consumes around 150 megabytes on average. So let's start with our adjustment. I'm going to stop this setup and let's do our implementation. So first of all, we're going to add dependency with a Hazelcast. So application will be able to use it. I'm going to use specific version because I'm pretty sure that it's working. Then after adding dependency, we need to add configuration for our Spring Boot application. And we need to create Hazelcast instance bin. Hazelcast instance is just an interface that provides access to a cluster. So some level of abstraction. It's as easy as just these few lines of code. But what we need to pay attention, of course, if we're using Spring Boot, Spring takes responsibility of lifecycle for every single bin, including Hazelcast. how we created here. We need to spin up Hazelcast instance together with application, and we also need to shut down it gracefully together with application. For that reason, we need to specify destroy method. To make sure that our application going to kill Hazelcast bot as Hazelcast member as well. Of course, in Spring it will be after discovered by we will make it for explicit. And what I'm going to do also, I need to grab some statistic to see how long does it takes for Hazelcast to spin up in our application. For that reason, I'm going to measure a time. Okay, we're going to log information about time of creation for this bin in seconds. So now, after application startup in log, we will see how much time it takes to spin up a Spring. Yeah, before the Hazelcast application, we were able to spin up in 5 seconds. And also what we need to do. Right now, we provide configuration, we need to adjust controller. Instead of concurrent map, we're going to inject Hazelcast instance here. And going to get a map from it. So right now our application is ready to work with Hazelcast, but also we need to customize configuration. We need to provide a file with some configuration that's going to be, this line when it's starting new instance, we're going to read this file that we are supposed to create. And let's prepare it. We're going to give some name to our cluster, HZ cluster, let's say. And since we're going to use Kubernetes API discovery, we need to disable default DNS lookup. And we're going to do it with a following configuration. So network join multicast enabled false. Writing this property, we disable default discovery mechanism, and right now going to enable our custom Kubernetes one. Enable true. And also, since we're using Kubernetes API, we have to provide service which is being used for discovery of members. Service name. Let's call it Hazelcast service. We're going to create it in the next few minutes. So right now, since we prepare the configuration, we need to do small adjustment in Kubernetes. First of all, I'm going to copy paste Hazelcast RBAC for Kubernetes. This is the file that you should never write by your own. You just copy paste it from official GitHub repository of Hazelcast. It looks like this. We give some cluster role and do cluster role binding. And last thing we need to do is to add service for discovery. For selector, we're going to use our application, because application is going to expose it port number 5701, and type, let's use cluster IP. Yeah, one important thing here, we also need not to forget to expose container port. And we need to include this to our scaffold configuration file. Important note here, Hazelcast service, since it's being used for discovery, should be created before application deployment. In case of you using some tools like Helm, it's okay because it automatically creates services before the deployment. But if for some reason you're using some manual configuration and you maintain the order of files you apply, make sure that the service will be applied first. Otherwise, pods won't be able to find each other in the cluster. So let's quick check. Wedges configuration, wedges controller. We create configuration for Hazelcast, wedges Kubernetes structure, and scaffold. Yeah, it looks like we're ready to try it. And we're going to execute. Let's see. It will take about 20 seconds to recompile application and deploy it to Minikube cluster. And we're going to compare the results. Yeah, we see our application starting. Took some time. Yeah, we see the first member of the cluster up and running. It's a good sign. Yeah, finally, we see that all three members of the cluster successfully find each other. They form the cluster. And see in the logs, looks like we spent 13 seconds just to spin up a Hazelcast. And total application startup time increased almost like 3 times. Instead of 6 seconds, right now it's 8. Let's see the metrics. Yeah, it's updated with a delay. Looks like I show you. Yeah, we see it. Yeah, Hazelcast is just adding around 100 extra memory consumption to every pod. Yeah, and let's try if our application is working, which I'm going to get value from the cache. It says that there is nothing here. We put value into the cache and get again. Yeah, successful result. Okay, I'm going to kill this cluster and we're switching back to presentation and going to discuss pros and cons. So, advantages of this pattern. It's relatively easy to configure for developer, especially if you are using DNS lookup. And if you're using, of course, Spring starters, it's going to be much more easier than I did because I wanted to dive deeper and see how we could do it by our own hands. It provides you fast data access because your data is collocated with application, which is not a good approach, but it benefits slow latency here. It consumes less runs than any other pattern because we're using only one JVM. So Hazelcast and your application share memory space, and quite optimal option. But it provides a few drawbacks. We observe longer application startup time, which influence our scalability. Also, it's going to be some stress for your cluster, because every time you are going to redeploy your application, scale up, scale down, it from cluster points of view, there is a lot of work to do because they need to distribute partition. It may cause leader re-election, so it might be also some stress for your support team and deployment team because it brings some instability. Yeah, and like common drawback is like data is stored together with application. Of course, it's up to you to decide if it's bad or not, but I consider this as a bad approach. Okay, moving on to the next pattern is a sidecar pattern. Here, we're trying to achieve some level of isolation between our application and data. They still inside the same pod. It means we're going to generate local traffic between them, but at least it provides some level of isolation. And let's implement this pattern. So we're switching back to coding part. Let me just switch my branch. Yeah, the first step we're going to do is to adjust our configuration in code. Here we create instance, but right now instead of instance we're going to create Hazelcast client. For that reason, we need to update our configuration. We're going to use file with different name and a bit different structure inside. Anyway, we have to provide cluster name. And specify members we're going to join. As I previously mentioned, it's going to be a local traffic because they still share the same Kubernetes pod. That's why the configuration may look like that. Also, since we will have separate container for our Kubernetes, our Hazelcast members, we just need to create store this configuration somewhere in Kubernetes because it's right now is out of control for our application. And it's going to be like this. We're going to create a config map. And we're going to call it a second. Let's call it, it's just value. Cast config map. But instead of key value data structure, we're going to store original Hazelcast YAML here. So just copy paste everything we had in this file. Yeah, it's unnecessary, I think. Oh, and naming. Yeah, so now we store our configuration in config map, and we need to update our application deployment. This is a sidecar pattern. It means we're going to create one more container inside of this deployment. Let's call it Hazelcast. I'm going to use Docker images matches version of my library. To avoid some incompatibility issues. Now this container going to expose port 50701 instead of application, and also we need to let this container know about our configuration. For that reason, we create a volume. Let's call it Hazelcast config map. And we making references to Hazelcast config map. Okay, now we're going to bind a file from the volume to file system of Hazelcast container. And give it a name like here. So we do mount, and right now we need to adjust environment variables. What we're doing here is explicitly specifying the name of the file and the path which Hazelcast needs to read during application startup. Okay, file is specified, port is exposed, configuration is done, and it looks like, yeah, looks like we did everything we need. Let's execute it and see if it's working as we expected. And it may take some time. Yeah, looks like something goes wrong here. Okay, let's take it. Let's give it a few more seconds and see. Just going to check. Oh, yeah, my bad. I forget to include this config map in the scaffold. So let's start again. Yeah, now application starts in. I see some errors. And it says we set up a wrong cluster name. Okay, we just need to remove this file. HZ cluster, and what we have here, HZ cluster as well. Okay, let me just stop it and compare with my predefined setup to see what's going on wrong here. Looks like I forget to add some line of code. Oh, I made a typo. Cool. At least now we know it. So, yeah, and starting this time should be much more positive. Okay, it's not working again. So I just not want to spend a lot of time just waiting here. I'm just going to roll back to predefined setup and see if it's working. I'm just going to, anyway, it looks like this setup is not properly working. So anyway, steps are the same. So you just need to adjust your configuration, provide the file, create config map, and adjust the deployment. And that's it for this button. And let's switch back to our presentation and discuss pros and cons then. Advantages. Data access is still fast because it's local traffic. It's traffic between two containers. It brings some level of isolation for data in application, which is good. Also, implicit benefits, it's become language agnostic. Since we're using Hazelcast cluster, it provides library for a lot of languages like Java, Node.js, C++, .NET, Go, Python. Of course, for us as a Java developers, might be not a big advantages, but at least someone who writing code on different languages may consider this. Drawbacks. The startup of application is still long, the same as an embedded button. Scalability also a bit complicated because you right now have much more Kubernetes entities than in previous embedded button. It's still stress for your cluster while you scale up or scale down. It is going to restart it. And data is still stored together with your application, which is bad. So let's discuss next button is client server. Here we're going to isolate our Hazelcast completely from application and will act in a regular client-server architecture. When application through the network making request to Hazelcast to get some information from cache about logs, about counters, whatever. So let's try to implement this button. I'm going to write the code. It's going to remove everything I wrote here. Okay, so here is a place where we stepped. Right now is sidecar button implemented, and we're going to convert it into client server. So our application already acting as a client with configuration, but this time we're going to use not local traffic. We're going to make a request to another service. So this time Hazelcast service will act as a load balancer, not just only for discovery. It should look like that, if I'm not mistaken. Let me check my notes, SVC cluster. Because we're going to make a request to different application this time. Also, we're going to split application deployment and Hazelcast deployment. So right now, application deployment is only responsible for application part with your business logic, and Hazelcast deployment going to spin up Hazelcast pods. Like this, and we need to adjust Hazelcast service because we now use as a selector Hazelcast label. Yeah, we match it. What else we need to do here? Select selector, we update deployment service client. Technically, that should be it. Let me just double check. Service default is VC cluster local. Let's see how it goes. and we spin up cluster. Yeah, important note while we try and execute our cluster, that in real world situation, you're not going to write all this configuration by your own hands. Instead of this Hazelcast setup, you could find out-of-the-box ready solution like Helm chart or Kubernetes operator. It's as easy as like a few clicks to install it and set up. Okay, for some reason it's not working. Let me just try to restart Minikube. Maybe it's something related. Okay, right now I'm restarting Minikube in the background. It may take half a minute, I think, because something really wrong with the network inside this cluster. And let me just quick check configurations. The application deployment, Hazelcast deployment is totally separate. Hazelcast service made lookup by Hazelcast label, which is good. Hazelcast client also looks right. Just quick paste it to make sure it is the same. Yeah, it is the same. And yeah, okay. Looks like I forget to adjust the scaffold again. And it's going to be here. Let me just quick check if Minikube. Yeah, Minikube is up and running. And we try again. It will take longer this time because we need to pull images again because we form a new cluster. Okay, well, it's still trying to spin up. Let me just quick check if I didn't miss. Oh, this time it's successful. Yeah, it takes some time. But let's see what's going on if we're going to scale our application. Because in this pattern, is one of the benefits. We're going to scale up to 5 pods this time. And now you can see that our time we spent for Hazelcast connection establishment is just 1 second. Because this time we do nothing with Hazelcast. We just start up our application and it's established a connection to the cluster within a second. Okay, looks like our stuff is working fine. Let's switch back to presentation and discuss pros and cons for this particular pattern. Advantage. I think this is the easiest pattern to configure thanks to Helm. Again, don't do it manually as I did in this presentation. Use out-of-the-box solutions like Helm Chat, Kubernetes operator. It's very easy. Few lines of code, few clicks, and cluster up and running. Applications start up almost like instantly. We don't need to waste a lot of time to create new Hazelcast member, make sure it's connected to the cluster. So we unbind life cycles of application and Hazelcast, which is really good. So it's become easy to scale up, scale down, restart application. You have zero dependency of what's going on with Hazelcast here. Data and app completely separated on different layers. It's also language agnostic, but the big drawback of this approach is slow data access. In previous patterns, we use local traffic or we didn't use it at all in embedded. But this time, it's real network traffic. It increases latency of request response. It could be partially mitigated with such functionality called local near cache. It allows you to cache some data on your clients. Of course, it comes for price. Your data may become stale and your application will not be aware about it because you cache it on your client, but in central Hazelcast cluster, data might be changed. So if your application mostly reads, then it might be the case to mitigate this drawback. If it's like 50-50 or you mostly writes, then this is drawback. You need to face it and consider if this pattern is good for you. So these three patterns is main building blocks that you need to consider while you start in project and think about Hazelcast as in-memory data grid for caches, for your logs, for rate limiters, custom implementation, etc. But there are also two other patterns. Let's talk about them. First of all, we're going to talk about reverse proxy pattern, and Hazelcast memory data grid could not act as a proxy because it serves different reasons. That's why we going to see how it could looks if you're going to employ Hazelcast memory data grids in a supportive role to implement these patterns. Reverse proxy. So in case your application live their own life without knowing that their cache exists, that distributed log exists, that array limiter exists, you might probably want to have some API gateway which takes this responsibility on it. At this level, you implement any dirty tricks you want. And let's say we could use Spring Cloud Gateway as a proxy, and right now we have one instance. Everything will work perfectly fine because with one instance you could store everything in memory, and would be okay. But it brings some problem when it comes to scale up. If we bring new pod to this setup of our proxy, it becomes a problem because if request pass through proxy number 1, it may count the rate limiter, but if it comes from the second pod, it will be counted only in second pod. So it's like two different counters. And here's a place where Hazelcast could help. And it may looks like this. So yeah, I think you already recognized on the left part looks completely as an embedded pattern, and that's what I previously mentioned. It's Hazelcast in this pattern play only supportive role. And it could be the case for you if you want centrally apply some caching mechanism, rate limiting without bringing all these layers to your application. And another one, reverse proxy sidecar. Again, we're trying to implement it using some Spring Cloud Gateway and Hazelcast to share the state. I was trying to imagine when it could be potentially needed, but unfortunately, I didn't. because it's very weird implementation, and I just decided to visualize it just for fun. Because comparing to previous pattern, it inherits all benefits and drawbacks, but brings one more additional drawback. That's you complicate scaling up your application in this way, and it will actually do, and will consume more memory. And speaking honestly, in case of reverse proxy and reverse proxy sidecar, you might consider some different solutions. Maybe Nginx could solve it, maybe HA proxy, etc. I just visualize it here and try to describe how it could look if we have to use Hazelcast or we want to use Hazelcast. Technically, that's it about our patterns. Here, there are some useful links, code examples, very similar to what I shared on today's presentation, but with more example, like using a CP subsystem. It requires some high consistency. Links to Hazelcast blog, where they deep dive into all possible caching patterns for microservices, and a few other useful links. So if you want to find me, there's my contacts in GitHub, LinkedIn, and Twitter. And I think it's time for questions. So if you have something, don't hesitate, write it to a chat, and we have a few additional moments to discuss. Okay, I see that there are no questions, which means we complete our presentation. Thank you all for your time who was watching it, and see you